Dear students, I welcome you to this online class, and in this class we will learn differential equation and how to solve a differential equation. That will also be discussed or learned in this class. But this chapter consists of a number of classes, and this is the first one. And in this class we will learn or we will cover the following topics, which are number one, introduction. First, we will have a brief introduction on differential equations, and then some terminologies related to differential equation. And after that, we will go to some to solve first order differential equation. And one of the method is known as variables separable. And in this in the last of this class, we will solve some differential equation by using variables or separable method. So let us start this session with the introduction, and that first we need to know what is differential equation. So to define it, it can be said that any equation that contains differential coefficients, that means derivatives of different variables or unknown function, is called a differential equation. And you know that differential equation consists of unknown or independent variable, and another one is dependent variables. So there may be a function which is unknown, and our motive or our we will try always to solve a differential equation to find out those unknown variables or function, etc. And this is it should also be mentioned that solving of a differential equation means to find the unknown function, and this is called the solution or primitive of the differential equation. And broadly speaking, the differential equation are classified into two groups. Number one is ordinary differential equation, and number two is partial differential equation. So what is an ordinary differential equation? The ordinary differential equation contains only one unknown independent variable. So in this kind of differential equation, you can observe that only there is only uh, an independent, there is only one independent variable, and consequently total derivatives. See here this example. Here d2x by dt square plus 2dx by dt plus 3x is equal to 0. This is an example of ordinary differential equation. Why? Because in this case, see here, there are two variables are involving in this relation. Number one is x and number two is t. See also that t in this case is the independent variable, whereas x is the dependent variable. So in this case, you see here that only one in there the number of independent variable is only one. That means t only. So this belongs to ordinary differential equation. But for the second, this one, just see this equation. It is d2 u by dt del t square del t by del t square is equal to c square del t by del x square. In this relation, see here the dependent variable is u, but the independent variables are two, and one is t, another one is x. So in this sense, or from according to the definition of ordinary differential equation, this equation is not an ordinary differential equation. It is somewhat different one. So now come to another one, that is partial differential equation. So partial differential equation is defined in such a way that this kind of differential equation will consist more than one independent variable. So as I discussed that in this relation, in this equation, there are two independent variables. One is t, another one is x. So in this sense, it is not an ordinary differential, rather it is a partial differential equation. And now come to the point that if you solve a differential equation, then you know that you can easily find out the unknown variable or unknown function. And in case of solving a differential equation, you actually are going to discuss a physical phenomena. because in physics you can describe a physical phenomena, or you can represent a physical phenomena by using differential equation. And this is different, and obviously that physical phenomena will satisfy some certain boundary conditions. And if you solve differential equation which obey that which obeys that physical phenomena, and you impose the boundary conditions, then you will get the certain solution of that physical phenomena. Because if you solve a differential equation, there are several possibilities, there are several solutions of the differential equation. However, if you impose the boundary conditions, then only one suitable solution will be observed. That's in this sense, it is no it is not very difficult to understand that if you use boundary conditions, then you will able to obtain the most suitable solution among the several solution of a differential equation. So come to next section, that is some terminologies, and in this section we'll know some terminologies related to differential equation. First of all, first one is the order and degree of equation or differential equation. So it is very important to know what is the order and degree of a differential equation. So first one is order. The order of a differential equation is the order of the highest derivative. That is, if you have given a differential equation, so first you have to observe the highest derivative involving in this differential equation, and then you have to find out the power of order of the derivatives. So simply it is defined as, that is, order of the differential equation is simply defined as the order of the differential equation, order of the highest derivatives. That is the highest derivative that involved in that differential equation. For example, see here, this is a differential equation. It is given here. So it is d2y by dx square plus dy by dx whole square, that is equal to xy. So see here, this is the here the derivative is first order, and here the derivative is of second order. But this is the highest derivative in this relation of x with respect to x. So the highest derivative is d2. The order of the highest derivative is here 2. So the order of this equation is 2, and so very often it is called second order differential equation. So if the order is 2 for a given differential equation, then it will be said a second order differential equation. However, if it would have order 1, then it should be called a first order differential equation. So it is clear what is the order of a differential equation. So now come to the next one, what that is the degree of a differential equation. And degree of a differential equation is defined as the highest power or highest power of the highest derivative. That is in this case. So here that is here the highest derivative is d2y by dx square. That is the order of the this equation. Highest derivative is 2, and its power is 1, because you can write that this term d2y by dx square as d2y by dx square to the power 1. So the degree of the highest derivative is 1 here, and the degree of the highest derivative is actually known as the degree of the equation. So in this case, the degree of the equation is 1, and it is very often called first degree. So this equation, the equation that is given by this equation number 3, that is d2y by dx square plus dy by dx whole square, that is equal to xy. This is the degree of this equation is 1, and its order is 2. So now come to the second one, d2y by dx square plus dy by dx to the whole half plus xy is equal to 0. So in this case, you have to first rationalize this equation. That is, there should be no fractional part. So if you see here, in this case the power is half, so if you rationalize it, then you have to square both sides of this equation. If you once square this equation, then the highest power, that is d2y by dx square, x square, should have a power of 2. So in this case it is second order and degree 2. So this is so in this equation is a kind of second order and its degree is 2 or second degree. Now come to another one, that is linear equation. A given differential equation is said to be a linear if the dependent variable and all its derivatives occur in the first degree, that is its power is 1 without a product of the dependent variable and derivatives. That means you have given a differential equation. Now you have to first observe or first find out that the degree of its derivative, highest power degree of its derivative. And if you see that the degree of its derivative is one, degree will actually give you the or identify whether it is a linear equation or not. So to do this, you have to first observe the differential equation, and it should be said a linear if the dependent variable and all its derivatives occur in the first degree, that is its power is 1. And obviously in this case there should be of absence of product of the variable or derivative, so there should not be the product of the variables or derivatives. So to understand this, just let us this example of this one, L di by dt plus Ri, that is equal to Et. So in this case she see that there is no product of the independent variables or derivatives, but also in this case the degree of the derivative is 1 because di by dt, and its power is also 1. So it is a linear equation. But if this equation have the power of this derivative as 2, that means L di by dt whole square, that is in this case power is 2. So it should not be a linear equation in that case. So linear equation should have the power of the highest derivative as 1, and there should be no multiplication or product of the independent variables or the derivatives. So this is an example of linear equation. So come to another example, that is here d2y by dx square plus alpha dy by dx plus dy. So in this equation, see here it is second order, but its power is 1. So it should be treated as a linear equation. However, the general form of linear equation can be represented as this relation, this equation, that is a0 d2y by d to the power m y by dxm plus a1 d to the power m minus 1 y dxm minus 1 plus etc. In this way, this term is a to the power n minus 1 dy by dx plus a n y, that is equal to 0. So here for all these cases the power of the highest derivatives or all the derivatives is 1. So it is a linear equation, and a0, this a0, a1, that is all the a's are function constant or function of x. And these expressions and all those expressions which does not have this form, that is that cannot be expressed in this form, are called non-linear equation. Okay, so and there are two types of solution of differential equation of order n. These are, what are these are a complete or general solution, and this contains many independent constant as in the integer of the equation, and as in is the higher of the equation. So if you solve a differential equation which has a different many differential derivatives, so if you solve that, there will be many independent there will be many independent constants, because it will depend on the order of the, this is the order of the differential equation. And number two is a particular solution. Yeah, because if you solve this type of equation, there are several derivatives are there involving in this equation. So if you solve this, there will be the several possibilities of solutions. So you will have a number of solutions, but you only have to use only one solution, which can be achieved by using boundary conditions, as I say it earlier. So among different possibilities of the solution of a given differential equation, you can obtain only one solution, one general solution, which is the best suitable one by using or imposing the boundary conditions. So this is all about the terminologies. Now come to the section, that is solution of differential equation. And the number one is, since we are already only discussed about the first order differential equation, so we will solve first order differential equation in this section. And you know that the first order differential, the general form of the first order differential equation can be written as dy by dx is equal to fxy. So just here remember, or just to look at this, that the generally the first order differential equation can be represented by this equation, that is dy by dx is equal to fxy, where fxy is a function of both x and y. Now we have to solve this problem, solve this relation, solve the equation, and the solution of this equation can be made by different ways, different by methods, which are here which are given here. Number one is equation solved by separation of variable. This is, we will first discuss about this method, then by homogeneous equation, by making equation to its homogeneous is by making an inhomogeneous equation to homogeneous equation. What is homogeneous equation, what is non-homogeneous equation, we will learn about after the next class, but here this is another method. Number three is exact solution, and number four is linear equation. However, we will solve a differential equation using first using separation of variable method. Here is the separation of variable method, and what we have to do in this method will be discussed here. So now, as we already have seen that the general form of the first order equation is dy by dx is equal to fxy, as I told earlier that fxy is a function of both x and y. And you can in this method, that is since f is a function of both x and y, you can separate this function by multiplication of product of two functions which are exclusively function of x and y. Say fxy is written as small fx and gy. That is, fx is only function of x and g is the function of exclusively y. And if xy can then be written as the product of these two separated functions, and that is you can write fxy is equal to fx and into gy. And in this case, so the variables x and y are separated. And now using this equation, that is substituting this value, that is fxy as fx and gy in this equation, you can write it as dy by dx is equal to fx and gx. Now just simplify it, that is you write this gx here, so dy by gy, that is equal to fx into dx. So now integrating both sides, you will have dy by gy, that is equal to fx dx. After completion of this integration, you can easily find out the value of y. But in this case, some special cases are here, some cases are to be noted. Number one is if y is absent in this equation. So that is in this equation, so the given equation, that is this dy by dx, that is equal to fxy. That means in this case the function y is not present, so it is absent here. So in that case you can write that dy by dx is equal to fx, that is, it is only exclusively the function of x. And from here dy can be written as dy is equal to fx and dx into dx. Then just integrate both sides. Integrate both sides, and after being integrated, this equation will give you y is equal to integration fx dx. And after after completion of this integration, you can comfortably find out the value of y. And next one is, if you consider that this function, if xy in that function x is absent, so in that case this function that is given in this equation, see here, in this case x is absent, so this equation, that is dy by dx, should be only a function of y, that is fy. So that is written here. See here, um, that is written here, dy by dx is equal to fy. Now from here dx is equal to dy by fy, and from if you integrate both sides you will have integration dxy is equal to integration dy by fy, or x is equal to integration dy by fy. After computing this integration, you can easily find out a relation between x and y, and hence y can be calculated. Now come to the next condition, next discussion, that is if both x and y are absent there. So this is a case. So in this case, both x and y are absent. That means the right hand side of this equation, that is dy by dx, that is equal to fxy, that should be a constant, because x and y, the right hand side is not bearing the variables x and y. So it is a constant. It may be a zero. So we take it as a. So then you can write dy by dx is equal to a, or dy is equal to a dA, or y is equal to a, y is equal to, if you integrate this equation, it will give you y is equal to a dx, and after being integrated, this will result as ax plus c is a constant, and the solution from here you will have the solution as y is equal to ax plus c, and this c and this a are constants, and the constant of integration, that is c, can be calculated by using the boundary conditions, if you once have given these boundary conditions. So in this sense, the boundary condition actually provide you the value of the value of this constant c. Now come here in this section, we will solve some differential equation, and the first one is here, dy by dx is equal to y plus 1 by x plus 1. So this is the function of y, x, and this is a function of x. So, and the order of the power of the first, it is here, the derivative is first order, and or power is 1. So this is a linear equation, and you can solve it the method that already discussed. So to solve this equation, just write this equation here, dy by dx is equal to y plus 1 by x plus 1. So see here, in this case, fx is equal to 1 by x plus 1, and gy is equal to y plus 1. So from this equation you can write dy by y plus 1, that is equal to, because you know that to solve this equation the method was dy by gy, that is equal to dx by gx. Sorry, that is equal to gx into dx integration. So just or you can easily write from this relation that dy by y plus 1 is equal to dx by x plus 1. So now you know that the differentiation of these will give you dy. So dy by this, you know the form of the integration, that dx by x is equal to log x. This is natural log. So if you differentiate this, you will have dy. So this is basically the form of dx by x. So you can write from here that the integration is ln log y plus 1. Similarly, this will provide you log x plus 1, and here plus log c. Log c is a constant of integration. So, and it is an arbitrary constant, and its value can be calculated by using boundary condition. However, in this case no boundary condition is given. If we have some boundary condition, then we will able to calculate the value of c. However, from this relation you can write ln y plus 1 is equal to log y plus 1 is equal to log x plus 1 plus log c. From here you can write log y plus 1 minus, if you take in this side, minus log x plus 1, that is equal to log c. Or from here log y plus 1 by x plus c is equal to log c. Or from here y plus 1 by x plus 1 is equal to c. Or y plus 1 is equal to c into x plus 1. Or from here you can just simplify this, cx plus c, and this one is taken here, minus 1, and just write c minus 1 as d. This is another constant which is nothing but c minus 1. So y is equal to cx plus d. Okay, this is the solution. This is the required solution of the given equation. Now if you have given a boundary condition, that is For x is equal to 0, y is equal to 1. If you have given this condition, then just impose this condition to this equation, that is the solution. So here y is equal to 0, sorry, y is equal to 1, and then for x is equal to 0. So using the value of y is equal to 1 and x is equal to 0, you can easily understand that d should be 1. So d is equal to 1, and again using the value of d, using the value of d, you can write this equation as y is equal to cx plus 1. Now you need to know the value of c. To know the value of c, you will also have to you have also to impose the boundary condition in this equation, that is y is equal to 1 for x is equal to 0. So and this will give you, here c is equal to, from this solution you can write c is equal to y plus 1 by x plus 1, that is equal to y is 1 and x is 0, that will give you 2. So C is 2 and D is 1 as calculated. So you can write from this relation y is equal to C is equal to 2, so that means 2x plus 1. So this is the complete solution. So it is rather important and it is very interesting, because if you have given a boundary condition, then the arbitrary constants, that is the constant of integration, can easily be calculated, and the complete solution can be achieved in this way. Now come to another problem, that is solve the differential equation 1 plus y squared x plus 1 plus x squared dy by dx. So it is worth mentioning that this equation is a linear equation, and this equation has written here, and from here you can write, see here, this is equation x into 1 plus y squared dx. This dx is taken here, and 1 plus x squared dy. And now divide both sides of this equation by 1 plus x square into 1 plus y square, this term. So that will provide you x by 1 plus x square dx plus dy by 1 plus y square, that is equal to 0. Now integrate both sides, that will give you x by 1 plus x square dx plus dy by 1 plus y square, that is equal to integration of 0 dc, actually 0 d integration of that will give you, the right hand side will be a constant, because constant. And now to calculate the value of this, you just write that this, just omit this one, this is mistakenly written here 1, just write x square is equal to z. So this, be careful here, just omit this one because it is written here mistakenly, just to take as x square is equal to z. Then from here 2x dx is equal to dz, or x dx is equal to half dz. So from this relation x by 1 plus x square dz, that will provide you 1 by 2, then dz, and these will give you 1 plus z, that is equal to, you know that dz by 1 plus z, it should be the integration of these will give you log 1 plus z. So therefore integration x by 1 plus x square dx is equal to half log 1 plus x square, just substitute here the value of z. Now the right hand side, it is here, the second term, sorry, the second term, dy by 1 plus y square. You know that this form of integration has the solution, has the value tan inverse y. You know that because you know that dx by 1 by x square is equal to tan inverse x. This should be this should be x, tan inverse x. So writing these two terms, you have from equation, this equation you can write from this equation, you can write from this equation, this is equation number 1, that half log 1 plus x square plus tan inverse y is equal to c1 is a constant of integration. Or from here you can write tan inverse y is equal to this c1 minus half log 1 plus x square, and that is equal to c log c, where c1 is the constant, and this is taken as log c here also, then minus log, these you can write these as 1 plus x square to the half, or tan inverse y is equal to log c by root over 1 by x square. You can write from this relation this, because minus sign is there, so it will be divided, and it should be in the here. So now from here y is equal to tan inverse log c by 1 plus x. So this is the complete, this is the solution. And now come to the next one, now come to the next solution, next problem. This problem is find the solution of the given differential equation sin x dx plus dy by root 2, that is equal to 0, subject to the boundary condition, that is x is equal to pi by 2 and y is equal to 3. So the equation is written here, and just integrate both sides of this equation. you have sin x dx, that is dy by root y. See, it will give you, see, the constant. So from here, sin x dx is equal to, you can write is y to the minus half dy, and then this will give you minus cos x, and this will give you 2 root y, because the 2 will be, this is the complete process steps are written here, just to go through this. So finally you have and there you obtain that minus cos x plus 2 root y is equal to 3. Now the boundary condition that is given is what is that? That is for x is equal to pi by 2, y is equal to 3. Now just substitute these values, or use this value. So from here, from this relation you write cos pi by 2, x is pi by 2, then 2, y is 3, root 3. That is equal to c. From here you can easily obtain that c is equal to 2 root 3. And then from this relation, that is equation number 2, minus cos x plus 2 root y is equal to 2 root 3, because c has the value 2 root 3, or from here 2 root y is equal to here 2 root 3, then plus cos x, and this 2 is taken as here 2. So y is equal to 2 root 3 plus cos x by 2, and this is y to the half, and then y should be squared this term, square of this term, or square of this term. So this is the solution. Now come to the next one. Solve the differential equation, that is here is given y dx minus x dy. This is very simple one, and the solution is here given. So you just to go through this, and it is not very difficult to understand. All the steps are given here. So finally we obtain x is equal to cy. And next one is here, another one is another, solve the equation dy by dx is equal to cot x tan y. And this equation, from this equation, the given equation is this. From here you can write dy by tan y is equal to cot x dx. And now just divide this tan x tan y, right, tan y as sin y by cos y, and this cot x by cos x by sin x dx. So after that, you can obtain from this relation that cos y by sin y into dy, and then here sin cos x by sin x dx. Now integrate both sides. Integrating both sides, and you know that the differentiation of sin y is actually provide you cos y. So you can write this relation, this equation, this term as d of sin y by sin y. And similarly, this can write as d of sin x by sin x. And you know that this is the form dx by x. Integrating this, you can write log sin y is log sin x plus log c is a constant, and after from this you can finally obtain sin y is equal to c sin x. So this is the solution. This is the solution. And here is another problem is here, dy by dx plus log x to the power y is equal to 0. And here a boundary condition is given. The boundary condition is y is equal to 1 when x is equal to 0. Or you can read as y tends to 1 when x tends to 0. So the given equation is this. This is the given equation. Just write it as dy by dx from this relation. Dy by dx you can write as minus log x to the power y, and you know that the power can be taken here. So that can be written as minus y log x. And from here dy by y, this y is taken here, then minus log x dx. Just integrate this. After integration, after the integration, you have two term dy by dy by y, that is equal to minus log x dx. Now you have to compute this integration. To compute this integration, you have to apply the method of integration by parts. By now here integrating by parts, you know that you can write ln x log x dx. First log, write here log x, then integrate dx, then minus integration of differentiation of this log x, and then differentiation integration of dx, and after the dx, because you know that integration uv is equal to u integration dv, then minus integration dv by dx, then integration du by dx, then integration of v and dx. So you know the rule, so formula. So from here it is x log x minus, from here log x is differentiation of log x is 1 by x, and indeed dx is x dx. So x log x minus dx. So it is not very difficult to calculate this. So finally you get x log x minus x, and it is a constant. So from this relation, that is equation number 2, you can easily write it log y is equal to minus x log x, then this x should be a positive sign, and then c minus c is here, so minus c is another constant. Take c1, minus c1 is another constant, that is taken as plus c. So from here tan y is equal to minus x is taken as common, log x minus 1 plus c. Now the boundary condition was y is tends to 1 when x tends to 0. So just write it as substitute the value of y and x in this expression. So here log 1, that is equal to x is 0, so 0, and this term is c, and log 1 is equal to 0, you know. So from here you can easily write that, you can easily find the value of c as 0. So c is 0 in this expression and this solution. So you can finally obtain the finally write y is equal to minus x log x minus 1, or y can be written as e to the power minus x log x minus 1. So this is the final solution. And in this section or in this class, we actually we understand or we know how to solve a differential equation by using separation method of separation of variables. So this is the end of this class, and you need to go through all these solutions, and then everything will be clear to you.